Hello, lovely students. This is Mrs. Berger. I'm going to go through your Unit 1 study guide so you can check your answers along with me as I solve each of the problems. Mr. Lamb and I are so sorry that we cannot be with you today. We got our second dose of the vaccine and are feeling under the weather, so we pre-recorded this just in case we were having some side effects. If you have any questions, make sure you message your teacher to check over your work and to clarify any answers or questions you may have before your Unit 1 assessment on Friday. All right, so let's go in and solve these problems. So let's start with this first one. It says choose the numbers that are integers. Well, remember, an integer is a whole number. Its mathematical opposite or zero. So negative 45 is an integer. 6 is an integer. Even though it has that 0.0, 6.0 is the same as 6, so that is an integer. 0 is an integer. 4.9, nope, because that has just a little bit more. And then I have these two improper fractions, 11/3 and 8/2. So I'm going to pull over my Desmos calculator to show you how to check these improper fractions. So remember, a fraction bar means division. For 11/3, I'm going to do 11 divided by 3. Oh, I get a decimal. Nope, not an integer. 8 divided by 2. Whoop, I get that whole number 4, which means that is an integer. So those 4 options are integers. All right, remember integer, whole number or its mathematical opposite. All right, let's look at the next one. It says identify the integer represented by the point on the following number line. So here I have 0, positive 5 to the right, negative 5 to the left. Well, I have that dot kind of in between that 0 and negative 5. So let's jump to the dot to see what we get. So I have negative 1, negative 2, negative 3. That dot is at negative 3. All right, let's look at the next one. It says, which point on the number line is represented by the integer with the least value? So least means left. So I'm going to look for the number all the way to the left. It doesn't matter if these are all positives or all negatives, but we're going to go all the way to the left. And right here is our smallest number, so it's A. Remember, left is least. All right, write an integer for the situation. I deposited $50 into my bank account. Well, when I get a deposit in my bank account, I'm happy because that means money's going into my bank account. So deposit $50 would be a positive 50. So just 50, right? Positive 50 when you deposit. Remember, withdraw, negative, deposit, positive. All right, for this next one, it says compare using less than, greater than, or equal to. So negative 24 is what to 8? Well, a negative number is always smaller than a positive number. So negative 24 is less than 8. I'm going to choose this one right here for A. For B, negative 12 is what to negative 9? Well, on that negative side, it's like opposite world, right? The bigger your base number, the smaller it actually is. So negative 12 is less than negative 9, right? Because it's more to the left. And then for C, negative 56 is what to 61? Well, again, a negative is always less than a positive. So all 3 of them are less than. Less than, less than, less than. That won't always happen, but it did this time. This one says, arrange the numbers in descending order. To descend, think of that word, descend means to go down. So you're going from greatest to least. Descend, we're going down. So if I have the numbers 0, -3, 4, -2, and 8, I want to start with the biggest number. So 8 would be my biggest number because that's my positive, my big positive. Then I have 4. So 8 is greater than 4, which is greater than 0, which is greater than -2, which is greater than -3. So I start, when I descend, you're going to start with the biggest number and go down. 8, 4, 0, -2, -3. If it said ascend, then we would flip that. We'd start with little and go big. So ascend up, descend down. Now let's look at our integer model. It says, which expression is represented by the model below? So let's look. I have 4 groups of -3, which gives me a total of -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have -12 split into 4 equal groups. So I'm going to choose this -12 divided by 4, right? They're not in 3 groups. There's 3 in each group in 4 of the groups. So I have -12 and I divided it into 4 equal groups. Would be how you read that little fancy model. All right, what is the value of the following expression? Now remember, technically we're doing integer operations without a calculator, but I'm going to show you how to check it in your calculator here in a minute. So let's think back to integer operations. Remember when we subtract integers, we use the process called keep, switch, switch. So I have -12 plus +2. Okay, so now I have to add these integers. When I think of the rules of adding, it's same sign add, different sign subtract. Same sign keep the sign, different keep the larger. So those are different signs. I have one negative and a positive. They're different signs, so I subtract them. 12 minus 2 is 10, and I'm going to keep the sign of what I have more of. I have 12 negatives or 2 positives. I have more negatives. So my answer is -10. If I wasn't feeling super confident about that, I would just pull up that Desmos calculator. And I'm going to type it in. -12 minus -2. Boom, -10. I'm basically a genius. I pat myself on the back and I move on to the next question. All right. Oh, this next question. This next question is an order of operation problem. Remember those long jail markers, those jail bars right here? That means absolute value. That's a number's distance from 0. -6². Whew, they gave us a lot here. So we're going to solve our grouping symbols first. I'm going to solve that absolute value. The absolute value of -9 is +9. -9 is 9 spaces from 0. Plus -4, I'm going to simplify that. When I add a negative, I'm really subtracting. -6². I'm going to solve my exponent first. 6² means 6 times 6, which is 36. So now I do 9 minus 4 minus 36. Okay, 9 minus 4 is 5 minus 36. And when I have 5 and I take away 36, I'm going to go in the -31. Now, maybe, just maybe, you're like, Ms. Berger, what are you talking about right now? I don't want to do any of that in my head. Well, let's take up our Desmos calculator and let's check out to make sure we got the right answer. When you put in absolute value, you're going to use this key right here, absolute value of -9. You're going to close that out. Oops, you're not going to do that. You're going to close it out. There we go. Minus, parentheses, -4, minus 6². -23, -31. What just happened? What did I do wrong, guys? Let's go back. Oh, because it says plus -4. Oh, geez. All right, let's go back. See, this is why it's always good to check your answers. Plus -4 minus, got it. Here we go, guys. Woo! Oh, man, teachers make mistakes too, and it's okay. We're going to keep rolling with it. So absolute value of -9 plus -4 minus 6². So it's always good to make sure you typed in your problem the way that it was written on your test. And I'm just modeling that for you to make sure that you don't make that same mistake. So -31, -31. Here we go. Now we're winner, chicken dinner. Whew! Now that we made it through that order of operation problem, let's forget that ever happened to us. Whew! Geez, oh, Pete's. All right, let's move on to this kind of weird thing. What's happening down here? Remember, this little sign means the square root of. The square root of 289. Lucky for you, you have that calculator. So you're going to clear this. Remember, for square root, you're going to hit this button. The square root of 289 is 17. That means that 17 times 17 is 289. Nailed it. All right, let's go to our next question. The coordinate plane. Let's label the parts of the coordinate plane. All right, so part A is over here in quadrant 2. Right? Remember, 1, 2, 3, 4. B is pointing at this long line right here, which is the x-axis. C is over here in quadrant 1. D is pointing at this long, oh no, sorry, D is pointing to the middle. Whoop, D is pointing to the middle, which is the origin. E is over here in quadrant 3. Remember, we write them with Roman numerals. F is over here in quadrant 4. And G is pointing to this long, tall, skinny, up, down, vertical line, which is the y-axis. So remember, 1, 2, 3, 4. X side to side, Y up and down, origin in the middle. We're getting so close, guys. All right, identify the location of the point -3, -4. Well, if I don't have a coordinate plane, I can kind of draw one, right? Here, it's just like a little cross. The lines continue on for eternity. All right, so if I have a -3, -4, that means I started at the origin and I went left, then down. Right here is quadrant 3. So I'm in quadrant 3, that negative. So even if you can't graph it, you can always make a visual for yourself and then travel in those directions to see what quadrant you end up in. Well, what if I have a location that's on an axis, right? So remember, if I have a 0 in my ordered pair, I'm on one of the axes. I'm either on the x-axis or the y-axis. Here's a little trick. If you put xy over top and circle the non-zero number, that's the axis you're on. I'm on the x-axis. I could draw that if I made my little like bootleg coordinate plane, right? I start at the origin, I go over 5, but I stay right there. I'm on the x-axis. So you can graph it or you can use a little trick. Either way, if your y is 0, you're on the x-axis. All right, moving right along. Here we go. We got another coordinate plane, a bunch of points that are plotted for us or ordered pairs. So let's go ahead and solve this one. It says, which point is located at -2, +3? Okay, so I start at the origin. I'm going -2, which means I go 1, 2 left, +3, 1, 2, 3 up. I'm at point B. Let's look at this next one. What is located at +2, -3? Start back at the origin. First number is +2, so I go 1, 2 to the right. Next number is -3, 1, 2, 3 down. I'm at point D. And then what is the distance between B and C? When we calculate distance on the coordinate plane, we literally just hop from one thing to the other. So here's B, here's C. I'm going to jump 1, 2, 3, 4, 5 spaces. They are 5 spaces apart. All right, well, here we go. Let's look at these. Choose the number that has the greatest absolute value. Remember, absolute value is just fancy words that means how far is this number from 0. When we calculate absolute value, it's always going to be a positive number because distance is always positive. So really, I'm just looking for the biggest base number. So the absolute value of -8 would be 8. The absolute value of 7 is 7. The absolute value of -4 is 4. And the absolute value of 9 is 9. So which one of those is the biggest number? 9 has the biggest absolute value. 9 is the farthest from 0 in terms of these numbers, right? So that's all that means. Absolute value, remember, I write it with those little jail things. Absolute value of -8 equals 8. The answer is always going to be that positive number. All right, let's move on to 17. It says a drone is flying 200 feet above sea level. it descends 75 feet before rising 125 feet. What is the altitude of the drone now? All right, let's not make that same mistake. Let's get my calculator out right next to my problem. Boom, boom. Make this smaller. Make this bigger. Ta-da, ta-da. Thanks for being patient with me, friends. All right, so here we go. We can use a calculator for this. A drone is flying at 200 feet above sea level, so that's positive 200. It then descends, remember, descend down 75 feet. So minus, oh, really? Hold on. Let's be mathematically correct. I'm going to add that negative 75, right? Or I'm subtracting. Before rising, so that's positive 125 feet plus 125. It is now at 250 feet. So is that oh no, 250 feet. So it was at 200, it dropped down to 125, it then gained another 125, so it's at 200 feet. All right, let's do some, oh, these are my favorite. Let's do some exponent problems. It says, based on the pattern below shown, what is 3 to the 6th power? So let's clear this. When I type in an exponent, I type in the base first, 3. Then I use the exponent key. Then I type in the 6. 3 to the 6th power happens to be 729. Isn't that easy? That's pretty easy. I love exponents. All right, which of the following is a perfect square that is between 196 and 324? Well, geez. Okay, well, first, which one of these are perfect squares? Remember, to be a perfect square, your answer has to be a whole number. So let's check to see which of these are perfect squares, and then we can maybe just find the answer. So all of them, well, first of all, not all of them are between 196 and 324. 342 is after 324, so I can eliminate that as an answer choice. The other 3 maybe could be the answer. So remember, perfect square means your square root is a whole number. So let's find the square root of 249. That is not a whole number, which means that is not a perfect square. I eliminate that answer. Let's find the square root of 256. Okay, that's a perfect square, so that's in the running. Let's find the square root of 300. Wait a minute, not a perfect square. So by eliminating all the choices, I'm left with the only one that could be right, which is the square root of 256, which is 16, which makes it a perfect square. Right? Isn't this great? So easy. All right, what is the exponent when writing 1 million as a power of 10? All right, guys, let's think back to powers of 10. Remember that rule. The number of zeros tells us what the exponent should be when our base is 10. So our base is 10. What's the exponent? Let's count the zeros. 1, 2, 3, 4, 5, 6. The exponent should be 6. I would write it 10 to the little 6 up there. Exponent is 6. All right, it's our last one. I'm going to show you guys a trick on this one. All right, it says the ordered pair of the vertices of a rectangle are given. Here's point A, point B, point C, point D. So if we graph this on the coordinate plane, it would make a rectangle if we connected the dots. What is the length of AC? All right, here you go. Here's how you do this without a coordinate plane. I'm going to write down A. Point A is at -1, 4. Point C is at 2, 4. Here's the trick for finding distance on the coordinate plane. I ignore the numbers that are the same. I'm going to ignore the y values. And then I want to find the difference between these numbers. So I just take the big minus the little. The positive one is bigger. 2 minus -1 means they are 3 spaces apart. Right? That's not too bad. I could also graph this if I forget this trick. So if I don't have a coordinate plane, I can really just draw, and then I have, what was it? -1, 2, 3. So sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so I'm going to graph A at -1, +1, 2, 3, 4. Boom, it's right there. There's A. C is at 2, 1, 2, 1, 2, 3, 4. Right? Here is C. So now I'm just traveling. 1, 2, 3. And it's not perfect because you don't see the grids, right? But here's the line for 1. Here's the line for -1. There's 0 in the middle. So then here is the 2. So I traveled 1, 2, 3 spaces. So if you have a coordinate plane, then definitely graphing it and just jumping is easy. If you don't have a coordinate plane, you can use this little calculating distance trick. But that is all. That is your study guide. All 21 questions. Your unit test will look very, very similar. So if you don't understand any of these questions and you want to clarify, we will be with you Friday before your test to answer any clarifying questions. You can send us a message because we're always here to help you, even if we're not feeling good. But wanted to record this just in case we had that negative reaction. So let us know if you have any questions. If not, we'll see you later. We love you. Bye.